Hello and welcome to another episode of Spec Steppin, where we are stepping through the web API spec. In today's episode, we're going to be covering device memory API. So you may have encountered this if you've done any development that may be utilizing robust like audio, video, or just robust memory. And it may be unrunnable, if I can use that word, on a device that has some memory issues. Either they have a lot loaded, or maybe it's an older device that has low amounts of memory. And you want to make sure your application runs efficiently and performs well, regardless of the end user's memory. So this has always been kind of a difficult thing to figure out how much RAM is in the machine, the device on which our application is running. So in comes the device memory API. With this API, we can figure out what memory is available on the device so that we can decide what to deliver and what to run as far as our application goes. Now, there is a somewhat of a limitation on this because there's some security issues. For example, the device I'm on right now has a 96 gig of RAM. So I never want to run out of RAM memory. So I beefed up the RAM. But you'll see when I do the demo, the device memory API is only going to show that I have 8 gig of RAM. And that's the maximum amount of RAM that it'll return, and it'll say it's approximate. So it gives an approximation, and it won't ever give the full RAM. Most people have more than 8 gig if they're on a modern machine, but it kind of does that so that people don't exploit the RAM that's in the machine. Again, the usage of this is geared towards I want to provide the best experience possible to my end users. And so I want to make sure that the amount of memory that the end user has is correspondent to what I'm going to deliver. Now, I just wanted to also show you that it's not available on every browser. So, for example, it's not available on Firefox yet. It's not experimental. It's just they haven't implemented that on Firefox, and it's not available in Safari. And so I'm going to run it in a Chromium-based browser. So you'll have to do this a little bit differently in those types of environments. And this documentation here on the MDN site does give information about client hints and things like that. And the only really qualification, other than it being available in the browser, is that it's got to run in a secure context. So let's switch over to the actual demo, and then I'll go back to my code. So what I have here is it's showing me that's 8 gig approximately. Again, I have 96, and it's showing that I have 8, and that's the maximum it'll show. And it'll tell me what quality tier it's in. So, and I'll show you that in my code. And by that tier, I can decide what to deliver. So here, I am delivering an image that's a higher quality image based on if I had a lower amount of RAM available. I could say, okay, if it's on a lower amount, deliver this image and not that image. You know, if I had a little less resolution image, a smaller file size, that sort of thing. And if I click recheck, it happens so fast that it rechecks it, but then it goes and fetches a new image. And I'll show you what that's doing. So it again reads the navigator device memory property of what the gigabyte is, picks a content quality tier, and then displays an image. So let me recheck it. There's another image of a nice elk. So let's switch back to the code here. So the HTML is pretty simple. I just have, a div with, I have my device memory div where you'll see that's corresponding to right here, 8 gig approx. It starts off with just the phrase detecting. And then a quality tier, that's right here. And what's the quality tier? It'll show up right here once it detects it. And then there's a little note, compatibility note. That's this note right here. And then I have the hero image that the source starts off as empty, but once I figure out how much memory the end user has, it supplies it. And then I just have a button to refresh that just will allow you to redo it. And then it's just a little note there. So, and then styles, nothing special, just some styles to provide it a little bit so it's not so blah. So let's jump over into code here. So in this code, we have a utility here that's going to pick the RAM value in the memory tier. So here's the values. If you look at the API, these numbers are here 0.25, 0.5, 1, 2, 4, and 8 gig. Those are kind of the tiers, are the common values that this API picks up. And so if it's beyond 8, eight's the largest it'll go. So but you can see where you're at. So again, the reason for that, intentionally privacy preserving. So it won't show the actual RAM that you have available so that nothing malicious happens. So I do some checks here if it's undefined or null, just for safety's sake. And then if it's less than 1, I return low. If it's between 1 and 4, I return medium. Otherwise, I return high. So mine returns high. So if you see here, my quality tier is high. So that's my memory to tier here. Okay, so down here, let me just jump down here and I'll kind of jump around here a little bit. Oops, sorry about that. So this update UI, that's the function that actually changes the user interface, obviously, by its name. So I pass in the memory value and I grab, and in fact, I just got in a habit of I'm trying to get in a habit of doing query selector. So let me just change these real quick because I like that better. Old habits sometimes die hard. Just refresh. And there we go. Picture of a fox. Okay, so first I grab the memory element, device memory, the tier element, the note element. So I grab the memory, the tier, and the note. So and then if the mem val, whatever I pass to it, is undefined, then I just say, hey, I update that element with emphasis. That's this one right here, where I say I pass through the meml element, device memory, not available. So let's look at what this does. Oops. So what this does is I pass through the element, what the label is on the element, and the value of that. So whatever that element is, I clear out the content that was there before. Then I create an emphasis element. So that is creating this right here, this emphasis element. And I put the value of whatever value is that I pass through in that emphasis element. So this value right here, I changed the text content to that value. And then I append that label and the emphasis back in. So if you look, I'm appending device memory, and in this case, not available. It would show device memory, not available right here. Okay. So one's inside an emphasis tag, one's not. One's just the label that goes before it. Okay. So then this compatibility note, I change the text content. So I say, okay, device memory not supported. So if it's undefined, it would say not supported. That would show up right here. And then update element with emphasis, quality tier, fallback. That's the tier. That's this right here. So again, update element with emphasis, same function as I did before. It's just saying, okay, quality tier, fallback, and I'm updating a different element. Okay. And then apply quality tier medium. So I apply a feedback, a fallback, basically saying, okay, give me the medium level. So if I can't find the memory, let's just serve up the medium if I can't find it. Okay. Otherwise, I'm actually going to pass the tier memory to tier method. So that's up here. So I'm passing through, let's walk through this here. I'm passing the memory value that it finds to here. So in my case, it's 8. So it's not defined, not null, and it's not less than 1. So that's not going to run. It's not between these 1 and 4. So that's not going to run. So it's going to return high, which is why mine returns 8 and high there. So let's go back down here. And then update element with emphasis. So again, device memory, the mem value, which mine was 8. That's updating this one right here. And then update element with emphasis, the tier, quality tier, high. It's right here. And then the text content, value provided by navigator device memory, approximate and coarse, right here. And then apply quality tier. That is, let me go back up right here, the second method. So this is what actually does the work on the image here. So I grab that hero image, refresh this. Here we go. So I grab the hero image. If my tier is low, so I'm passing that tier to it. So down here, I'm applying medium if I don't get the memory value. If I get the memory value, I'm applying whatever tier I get, high, medium, or low. So if it's low, it's going to do this image. So it's going to pick some, just grabbing a photo, random photo that's in the, it's going to be a low quality grayscale. Otherwise, it's going to do a medium image and a little higher res or higher it's, and then the default is a with the same thing as the medium. So let me just show you these real quick here. What I'm going to do is just alter this code just a little bit. So I'm going to just comment that out just so you can see there's a low quality. So it went and got the smaller image grayscale 600 by 320. And then let me do the medium one. So you can see that one. There's a medium. And again, it's a medium image, random image 900 by 480. Otherwise, it's going to do the high quality one, which is what I should get. And there's a higher quality image. Okay. And you could probably check in your over here in your in the network. See if it reports. Yep. See, here's where it reports the image that it got back. So you can see what sizes and stuff over here if that interests you. So then down here, I just have this in here because if you look at the documentation, it's available on web workers. And here I have a worker that I'm running. I wouldn't necessarily call this a genuine web worker, but it's just a worker that's actually doing the calculation for me, basically. So if that worker doesn't exist, it returns. Otherwise, it loads, it would load a new worker, worker.js, and it would post a message with the memory and the value. And, I have a console log that would post that, and I'm working with the note and all that stuff. So I'm just showing here just how you might, this is like I said, a quasi web worker. I didn't want to flesh that out fully, but just to show you kind of a little bit about how it would work with a web worker. That's for another video. So here, detect and apply, this is the main detect function. So this is where I'm saying, okay, go into the navigator, give me, excuse me, sorry, wrong pipe. Give me the property of device memory. And then I'm passing that to update UI, which I already went through up here with all of that. And then start worker and report. That's that worker, which isn't really a web worker, but it'll do. And then I'm wiring up the UI where I'm saying here on the refresh button, add the ability to run this function anyway. And then I'm initially running it when the page loads. So I'm just running it already. And then this is just a compatibility tip to say, okay, are you using HTTPS and localhost? If you're running it locally like I am, then it'll tell you have to run it and always serve up over compatible. See right here, that's what that does. Puts that text there. So again, this is just a quick demo. I just wanted to show you how you can grab basically spectrums of what the device memory is. So you can decide what to deliver to the end user to give them the best possible experience in your application. So you can deliver low resolution images, medium, high, or you could deliver video, low, medium, high, that sort of thing. Or maybe decide, okay, this feature isn't going to run in areas that don't have high memory, that sort of thing. So this is just a API that you can use to detect, again, what memory is available, what RAM is available on the end user's device, and then have your code react accordingly. If you have any questions, let me know. And if not, happy stepping.